In the vast universe, there's a galaxy whose star formation rate is estimated to be about 10 times higher than that of the entire Milky Way. Its name is M82, or more precisely, Messier 82, because its appearance at night looks like a cigar, as if the universe has lit it up in the darkness and is smoking it. It's also called the Cigar Galaxy. The story of the Cigar Galaxy is truly fascinating, and in this video I want to tell you all about it. So, if you're interested in the wonders of the universe, stay with me until the end of this video and don't go anywhere. Messier 82 is a giant, luminous, cigar-shaped galaxy that, instead of producing smoke, is busy making stars. This galaxy is actually a Starburst Galaxy, which means it's like a highly advanced star-making factory. A Starburst Galaxy is one that produces new stars at a much higher rate than normal. Interestingly, most galaxies usually form stars at a relatively calm and steady pace, but in a Starburst Galaxy, it's as if someone has hit the turbo button. Joking aside, this galaxy rapidly and intensely turns gas and dust into stars. But this situation is temporary because when you make stars so quickly, you run out of gas and dust fuel much sooner. To put it simply, M82 is located in a small central region, only about 500 parsecs or 1,600 light-years across, where the density of gas and dust is extremely high, leading to intense star formation. But this speed and intensity can't last forever because the raw materials for star formation are being consumed rapidly and will eventually run out. Let's see what causes this rapid star formation. Scientists say that about 100 million years ago, M82 had a close gravitational encounter with its larger neighbor, M81. A close gravitational encounter means that two galaxies got so close that each one's gravity disrupted the shape and behavior of the other, even if they didn't directly collide. Let me explain this with a simple example. Imagine two large ships passing by each other in the water. Their movement creates waves that disturb the water and shake both ships. Similarly, in space, when two galaxies get close, their gravitational waves cause the gas and dust inside them to shift. In the case of M82 and M81, these two galaxies got so close at one point that the gravity of M81 pulled the gas, especially the star-forming gas in the arms and outer regions of M82, toward M82 central region. This accumulation of gas in M82 center increased the density so much that a chain reaction of explosive star formation, or starburst, began. The massive, high-mass stars that form in such an environment have short lifespans and quickly turn into supernovae. When a large number of supernovae explode one after another in a small area, the pressure and shock from these events push the surrounding gas and dust outward. Imagine the center of M82 as a boiling pot whose pressure has gotten so high that hot steam or gas bursts out forcefully. On a galactic scale, the energy and temperature in M82 center have become so intense that hot gas is being ejected outward at high speed. These massive outflows of gas from the center are called galactic winds. In Hubble and James Webb images, these winds appear as red or orange filaments shooting out from above and below the galaxy's disk. Interestingly, the Hubble telescope has discovered several massive star clusters in the center of M82, each with a mass about 200,000 times that of the Sun. These clusters are dense, energetic star-forming regions, and because they continuously produce massive stars, there are frequent supernova explosions. These supernovae both eject gas outward and help shape the galactic winds flowing from M82 center. The most amazing thing is that these galactic winds can carry gas and metals from M82 center out into intergalactic space, meaning the raw materials for star formation are spread to other galaxies as well. In recent years, James Webb has shown that M82's galactic wind isn't just a simple flow. It actually follows a complex path, like a river with many branches and eddies. Additionally, these telescopes have detected complex organic molecules called PHs, polycyclic aromatic hydrocarbons, which are carbon-based and are among the building blocks for stars and even more complex structures. Data shows these molecules travel with the wind and spread from the galaxy's center outward. These observations have also pinpointed exactly which region of M82 center is responsible for launching these winds and ejecting material. But the story doesn't end here. It's still ongoing. On the ground, there's a telescope called Veritas, designed to detect high-energy gamma rays from space. In orbit, the Fermi Gamma Ray Space Telescope also specializes in detecting cosmic gamma rays. Using these two telescopes, scientists have been able to record gamma ray emissions from M82, providing clear evidence that this galaxy is one of the main factories for cosmic particles. In summary, M82 is like a creative chef who, knowing that everyone wants a taste of their sweets, sends treats to all the neighbors, distributing the raw materials for star formation to other galaxies as a gift. But predicting the fate of this galaxy isn't so simple. Scientists estimate that in the next few 100 million years, as M82's gas is gradually used up, the rate of star formation will decline. This wild starburst will slowly die down, and M82 will transform from an energetic, excited teenager into a calm, mature galaxy. Just like a teenager who gets tired of wild parties and prefers to read a book. On the other hand, some believe that the stars currently forming in this galaxy will eventually become supernovae, once again ejecting gas and energy outward. In other words, M82 is caught in a crazy cycle. It makes stars, explodes, makes more stars, explodes again. A kind of eternal dance with M82 as a tireless dancer who doesn't want to stop anytime soon. But of course, every dancer eventually grows old and needs to sit down and rest. In my opinion, M82 is like a cosmic fireworks show, reminding us that sometimes the universe likes to put on a spectacular display. All we can do is watch and enjoy the view. What do you think? Be sure to write your thoughts in the comments. The story of M82 tells us that the infinite universe is full of movement and excitement. It's as if galaxies themselves are alive, breathing, getting angry, losing their temper, and exploding. These collisions and encounters, like the close pass between M81 and M82, can turn ordinary galaxies into star-making factories. And thanks to advances in science and technology, and the use of telescopes like Hubble, James Webb, Fermi, Veritas, and others, we're taking step after step into the depths of the universe.